In this video, we're going to be going through our milling example inside of BobCAM for Rhino. Now to get started, we're going to make our stock, we're going to add in a tool crib, which I've already created and saved with the file, and then we're going to apply our toolpaths. We're going to have some 3-axis toolpaths to rough this thing out and really finish it. We're also going to go in and cut these pockets on the slots here, as well as drill all the holes. Now we won't be able to do these side areas here because we don't have any tools that are going to do that. And really, I would turn that on a lathe, just like most of this could be turned on a lathe, and then we could finish it with the mill afterwards. So to get started, I want to right-click on CAM defaults and say New Job. And to make this easier on myself, I'm just going to switch to perspective view. That way I can rotate my screen around as I choose. It'll let me rotate things around, kind of see everything, and pick my geometry a little bit easier. I don't really need all the other views that go along with this. So I'm just going to go into the stock wizard here. I'm going to choose my solid model as my workpiece and then say next again. Right here, I'm going to choose cylindrical stock and I'm going to use a bounding cylinder. And then I'm just going to say calculate stock, and it should find the geometry and kind of lock it into that. And then right down here, we see the diameter of 6 inches. We have a height of 3.5. I'm not doing any start or end face offsets, but if I did want to add in material to face off, I could add in that material here. Otherwise, I'm just going to scroll down to the bottom and hit the forward arrow. And then I could go ahead and pick my origin, which it ends up being right where I want it. I want to use top dead center on this round stock here. And where I have my part positioned, it naturally chooses the top dead center of the part. That's where I drew everything from. So I don't actually have to change the origin, but if I wanted to pick a different position, I could pick a different position. The big thing here is, remember, you have to have your filters turned on to be able to go and pick points or grid lines or whatever you want to pick. So I'm going to leave it right there at XYZ 0. And then if I scroll down, I have my work offset. So I'm going to leave that on number 1 for G54 or E1, the first work offset of my machine. And then in Z here, I'm just going to lift up 4 inches. And that's just for my simulation. Because I have the Simulation Pro, if I don't add a value into here, it takes the top of my part here and puts it dead center on the table inside the table. So this is just to lift it out, but it does not affect the G code in any way. From here, I'll just leave my clearance plane at 1 inch and then hit OK. Now, I've already gone and set up a tool crib for this, so I can actually right-click on where it says Milling Tools and go down to Tool Crib. And then right here, I'm just going to import my tool crib. And I'm going to find my folder where I put this. So I have my desktop, and then I'll go down to my part files for the BobCAM for Rhino getting started. And then right there, we have our mill tutorial tool crib. Now what this is going to do is it's going to load in all the tools that I plan on using during this job. So I'll open this up, and there is all 7 tools that I plan on running. So I have a 3-inch face mill. I have a 1/2-inch ball mill. I have a 3/8 flat. We have a chamfer mill, a center drill, and then a 3/8 drill and a 3/4 drill. So that's all the tools I'm going to need, and I kind of plan that all out beforehand. Now that I have the tool crib set up, I could just hit OK. And then I'm just going to check my material. I want to cut this out of aluminum, so I just want to make sure that's the material that shows up. And then right here where it says Machine Setup 1, this is where I can start adding my toolpaths. So I'm just going to blank out my stock real quick. And then I'm going to right-click on Machine Setup 1, and I'm going to start with a mill 3-axis. Now, the toolpaths that I'll be using are going to be the 3-axis Pro toolpaths, but you do have the ability to do most of this stuff with a Z-level rough and a Z-level finish. You might have to do some standard kind of pockets around the part just to get the flat areas. But in my case, I'm going to run an advanced rough, a Flatlands to clean up the flat areas, and then an advanced Z-level finish to finish the wall. So I'm just going to start with selecting geometry. So I'll say select geometry. And now when I go to pick geometry, if I'm trying to pick the entire model, then I want to go ahead and pick the entire model. So you could just drag a box over the entire model, basically grab every surface, and that's going to grab it for you. If you go in and just pick one, that's the only surface that we're going to look at to machine. So you want to be careful when you're doing this. So I'm going to close this down, drag a box over the entire part. And then right here, I could set up a boundary, but I don't have a boundary on this part, especially with a 3-inch tool. If I was to go set up a boundary, I'd be limiting how far that tool's allowed to go, and I'd have to come up with a new boundary that's at least probably about 1.5 inches larger on every side to let that tool fit in the area. So I'm not going to set up a boundary for now. The top of feature right here we'll see is at 0 because the origin is at the top of the part. And then I can just hit OK. Now after I do that, again, I'm not picking a boundary, so I'll just say next. Right here we have our feature page. So we have our clearance plane at 1 inch, our rapid plane at 0.2. So anytime we wrap it around the part, so say we go from this pocket to this pocket right there, we'll be at 0.2, so 200 thousandths above the top of part. Now the top of part can change, and when we get into doing these pockets, we need to make sure that it knows that this boss is in the middle. So we're going to have to leave the top of part to be able to clear over that, depending on where we wrap it from. And same thing's going to go for drilling. But if I was going from a hole to a hole and I didn't have a big boss standing up, normally the 200 thousandths will be applied from the top of feature up above. So in our case, just 200 thousandths above the top of part. The feed plane is used for where we feed from. So we never feed from the clearance plane or the rapid plane. We will always rapid down to whatever the feed plane is set to and then start feeding in. From here, I'll just say next, and I'm going to go ahead and choose my machining strategy. Now, if you don't have the 3-axis Pro toolpath, you could use the Z-level rough, the Z-level finish, and maybe a planer to get your flatter areas done. But in my case, I have the pros, so I'm going to use the advanced rough. I'm then going to come over here to the available operations, and I'm going to add in the flatlands. And then finally, I'm going to use an advanced Z-level finish, and that's just going to go in and really kind of finish the cone that's on the top of this part. From here, I'll hit next. Now, this page isn't super important, but it depends on what you're doing. The work offset is set to the work offset number that you're currently using. So if I'm using work offset 1 or G54, I just want to make sure that that says work offset 1. If you're doing a 4-axis move, you do have an option here for an output rotary angle, but it's really not the right way to do a 4-axis movement. The right way would be to use index systems. So we're going to ignore the output rotary angle. The arc fit button is kind of important. If you want arcs to output inside your G-code program, you need to make sure to turn that button on. If you don't turn that button on, everything is going to come out with line movements, and you're going to have a really long set of code. Next, we then have our advanced rough. So we'll see by default, it grabbed that 3/8 end mill. I'm just going to go up to the tool crib, and I'm going to choose my 3-inch insert face mill and hit OK. And it doesn't show really great, but really you just have to know what your depth of cut is for each insert. So there's my 3-inch insert mill. And then right here we have our tool number and height and diameter offset. The only important thing to really know here is if you're changing the offset. So if you're overriding your offsets to numbers that don't match your tool number, you're going to have to use these boxes here. If you're trying to have your height and diameter offsets match your tool number, just leave that unchecked. And don't worry about tool numbering for now. That's something we can handle at the end. Right here we have our coolant options. So we have off or flood, mist, air, or oil. Over on the right here, we have our feeds and speeds. So right now, I'm letting BobCAM figure out the feeds and speeds for me based on the tool material and based on the material I have chosen over here, which is a 6061. But if you had values and you knew what you wanted to run at, you could uncheck this, use system feeds and speeds, and you could manually come in and type your spindle RPM, your cutting feed rate, and your plunge feed rate. Or if all you have is the math that you want to break it down to, you could enter in your surface footage per minute, your feed per tooth, and your plunge feed per tooth, and we will actually calculate the feeds and speeds for you from that. We also have an option here called arc slowdown, and this is when we encounter an arc, do we slow down the tool at all? It's a percentage of whatever cutting feed rate you want to use, so I could go to 50%. So it's anytime I encounter an arc, it'll drop to 50% of my cutting feed rate. And all I'd have to do is put that there. But in my case, I'm going to leave that at 100%. So I'm just going to say 100. And then I can hit next. Right here for our patterns, I'm just going to use the offset in. This is kind of an exterior part. I want to take the material from the outside and work in. So I'm going to say, let's offset in. But we also have things like morph spiral, parallel, adaptive roughing or high-speed machining, as well as the offset out. So start from the inside and work our way out. We're going to do an offset in because, again, we want to start from the outside and work our way in. And then right here we have our method, whether we want to do a zig, so we keep everything moving in one direction, or we do a zigzag. Now, when we say zig, we'll notice down here we have a cut direction of climb or conventional milling. I'm going to go with a climb mill and then say next. Now right here's where we get to define what depth of cut and step over we plan on using. So for my depth of cut, I'm not going to go too crazy. I'm just going to say 150 thousandths. And then for my step over, I'm going to go 0.875. So a pretty hefty step over, but remember it's a 3-inch tool. So that's still only a percentage of that tool, about 25, 30%, a little bit more. So right here is the big trick. When we go to cut this, we're going to leave these big steps on the side of the part, these 150,000 depths and then these step overs. So I want to make sure that those steps aren't too aggressive for my finish tool to come in and actually clean up. So what I'm going to do is set a number of intermediate steps, which these are steps that come after the part's been roughed out. They're just added steps to go in and slice these big depth of cuts that we left on the part. So I'm going to set this value to 2. And then I'm not detecting any stock thicker than anything. So I'm going to leave that right at 0. Normally this is used to detect stock that's thicker than whatever you specify. And then that way it doesn't go in and cut every step. It just cuts the steps that are thicker than whatever amount you set. But in my case, I'll just let it run it. The machining tolerance is your allowable deviation of your toolpath. So as you run your part, this is how much that tool's allowed to kind of wobble around. By default, it's set to a 1/2 thou, which is a good level to be at, but you may want to come in, depending on what toolpath and depending on what kind of quality you need, you could set that to something like a 1/10. Now, it'll take longer to calculate, but it's going to give you a better toolpath overall. So I'm just going to leave that there at 1/2 thou. And then we have ignore holes and cut holes. And this really depends on the tool you're using. I have a 3-inch tool right now, so there is no holes that I can really fit into. So I'm just going to leave it on cut holes. Down here we have our depth options. So we could say go to the minimum or maximum of the machining surfaces. We could say let's go to the minimum or maximum of the stock. Or we can use both. So we're looking at the stock and the machining surfaces to make sure we go as deep as whatever the deepest is. Maybe the stock is lower than the part. We're going to go that low. So we'll leave it on both. And then right over here, we have our allowance for XYZ, or our global allowance. Now, global allowance is an allowance across every part. And if you're using the 3-axis standard toolpaths, it's essentially the only type of allowance you have. With these pro toolpaths, though, I could also say side and bottom allowance, and I could have this toolpath actually go in and clean up the flat areas, the bottoms of the parts, by itself, actually go in and just machine them. But I'm going to leave it on a global allowance, and then I'll say next. Right here we have our leads. I'm just going to plunge into the material. Really, we should be starting from the outside, and that's a big reason we didn't set up a boundary. We should start on the outside, plunge to depth, and then kind of feed into the part. So I'll say plunge. We'll do a single depth, and I'm not going to use any lead out. So I'll say next. Right here we have our options. And so rest roughing is the first thing we see here. This is allowing us to go in with a large tool, like maybe a 3-inch tool. And then we'd have a second advanced rough. And we're not going to do this, but with that second advanced rough, what we'd be able to do is set up a smaller tool and then in here tell BobCAM that I've already gone and cut it with a larger tool. And we define what that larger tool was so that when we calculate this toolpath, it's going to go in and figure out all the areas where that big tool should have been able to cut. And then it's only going to give us toolpath in the areas that still need extra cutting. So for us, this is the first advanced rough we're doing. We're not going to add rest roughing. You would do that on your second advanced rough. Right here, we have an option called Machine Flatlands. And this gives us 2 options, a minimum width of flatlands, which I have set to 50 thousandths, and then a maximum width of flatlands, which isn't on by default. You have to check this box to turn it on. But I don't have a minimum or a maximum really. I wanted to go in and machine flatlands. And the flatlands that this is machining is any area on the part that happens to fall between our depth of cut. So right now my depth of cut's at 150 thousandths. So if I had a floor, a little ledge at 100 thousandths, we would ignore that ledge first and then come back and clean it up later. Essentially, we want to hit whatever we set up for our depth of cut, which is 150 thousandths. So we hit our 150, we do all our passes at 150 thousandths, and then the machine flatlands allows the tool to go back in and hit any of these intermediate areas, any of these areas that fall in between our depth of cuts. Right here is boundary options. We don't have a boundary set up. And normally with a boundary, you use the center of the tool on the boundary. So the center of the tool runs along the boundary. But with these Pro toolpaths, you actually have a choice. If you pick a boundary, you could say keep the tool on the inside of the boundary or let the tool go outside the boundary, kind of offset it out without actually having to modify the geometry. Right here, we just have some smoothing options. So we smooth corners, we smooth our links. We could set up a smooth final contour and then remove any corner pegs. So corner pegs are areas that maybe if you have a really large step over, there leaves these little stand-ups on your part. This will actually go in when it gets to a corner, it will loop out and actually knock those pegs down. But really, this is just to relieve a lot of the jerky motion that could happen at the machine. It's trying to smooth out some of these options. And then right here, we have a choice of sorting by area. So meaning we finish an area before moving on to the next. Or we go by level where we take the whole part down evenly at the same level. So I'll go by area. And then right here's our intermediate steps. We say after the last depth step or after each depth step. Now what this links to is back here on the parameters page, we set up our intermediate steps. So this is just asking when do we output those intermediate steps? After the last or after each individual depth step? I'm going to do after the last depth step. And then I'll go next. Right here we have our links, no changes here, just going to use a direct link between groups. So between each path, I'll go direct. And then if we have any groups, we're going to go between them with a direct link again. Right here is gouge checking. Now gouge checking is a great feature. It allows us to pick geometry and say, gouge check, avoid this area, don't touch this area. The thing is, we could do a lot of that stuff with boundaries. And this being our first run through on this part, really don't have to think about that because I don't expect it to have any gouges, and I'm not going to go start assuming that there's going to be gouges until I watch the simulation. So I'll go ahead and hit next again, and right here we have our advanced feed rates. First thing we see is convert rapids to feeds. You'll find this on every toolpath in BobCAD, and convert rapids to feeds allows us to convert G00 rapid moves to G01 feed moves, and then we actually output a feed rate on that line. So you can tell it to use a feed move instead of a rapid move, and then you define what feed you want it to use during that move. So it's still doing the rapid move, it's just not outputting a G00 because this can lead to dogleg rapiding. Right here we have some options for our feed rates when we're linking. So we can tell it to use a specific percentage of our feed rate when we link. And then right here we have our adaptive feeds. So standard is going to just follow the same feed rate we set up. And then in this case, the adaptive or volume-based will look at the amount of volume that the tool's engaged in. So the amount of material it's engaged in at any given time. And in our case, we could actually slow it down when we encounter heavier cuts. So I'm going to leave it on standard and just go next. Right here we have our Flatlands. So the Flatlands is going to use the same tool. So I'll just go up to Tool Crib. And then I'm going to choose tool number 1, which is my 3-inch insert face mill. And I'll hit OK. And that's it. I'm not defining any feeds and speeds. We have our tool number here, our coolant here, and our feeds and speeds here. I'm just going to let BobCAM figure those out. So I'll go next again. Right here's my patterns. So we have 3 patterns. We have offset, we have parallel, or we have adaptive roughing. I'm going to go ahead and turn on adaptive roughing because that's going to be kind of that high-speed strategy. But not really. I'm going to go with a pretty aggressive step over still. So it's not something I really got to worry about. Right here we have our method of keeping it in one direction or doing a zigzag. So I'm going to say let's keep everything going with a zig, everything in one direction, and climb mill. Right here we get to set up our step over amount. So for this tool, it's a 3-inch tool. So I'll go with a 3/4 inch step over. Here we have our minimum width of flatlands. So that's the smallest flatland it's going to see and try and run. Right here we have our maximum width of flatlands. Our tolerance, again, set to 1/2 thou. And I really don't change that too much. And then right here we have our minimal curvature radius. What's the smallest radius? As we do this adaptive rough, what's the smallest radius that we're going to allow an output of? So it's at 40 thousandths. We're going to tell it to cut holes or ignore holes. Doesn't really matter. The tool's too big to cut any holes anyway. Right here we have our top and bottom of job. We're not limiting this. This toolpath only cuts flat areas. And then we're not going to leave any allowance because we are trying to finish this part. So we'll go next again. Right here's our leads. We have plunge, we have ramp, and we have spiral. And with that plunge, we could do a vertical, a parallel, a right angle, or a circular lead in. I'm just going to say let's keep it vertical. It should really only be plunging in if it plunges into material. It should only be plunging into about 15 thousandths. So we'll go next again. Right here's our options. I don't have a boundary, so center tool is fine. It's going to run along the basic geometry bounds that it sees. And then right here we have some of the same smoothing options as what we see inside of the advanced rough. And you will actually get more of these if you're not using the adaptive roughing. And then right here we can calculate from the tooltip or the tool center. Next we have our links, or how we connect from one pass to another. Again, with the adaptive roughing, we have a direct link and there is no other options. But if you choose the offset or the parallel, you will get more options here. Right here we have our gouge checking. Again, I can't see any gouges happening that I could think of, so I'm not going to pick any geometry for a gouge. This is 3-axis, so it's really doing a lot of the work for us. Right here's my advanced feed rate. So once again, we have convert rapids to feeds, and then lead in and lead out feed rate percentages. And then finally, we get to the advanced Z-level finish. So for this one, we're going to go ahead and use our 1/2-inch ball mill, because I want to finish the tapered side to that cone. So I'll pick my 1/2-inch ball rough end mill and hit OK. And then next. And now when I set this up, I'm going to tell it to start from the top and work its way down instead of going from the bottom up. Right here we then have our method. So we can do a zig, a zigzag, or a spiral. I'm going to go with just a zig, and then I'm going to go ahead and tell it to climb mill, and I'm not going to round any corners. So I'll go next again. Right here we have our depth of cut. So this is a finish pass, so we want to go with a decent enough depth of cut that we get a good finish. So I'll say 0.03. And then I'm going to turn on the adaptive depth of cut. Now the adaptive depth of cut allows us to let BobCAM go in and add extra toolpath where it sees it's necessary. So we're going to rough the entire part at 30 thousandths, but in the areas that need more work, I'm going to tell it it's allowed to go down to 15 thousandths. And then in the areas where even if it can't get to that 15 thousandths, it still has to output another toolpath, we could define it based on a step over. So how far does it travel before it steps over again and lays down a toolpath? I'll say 30 thousandths on that. So just 0.03. Again, my machining tolerance, I'm going to leave it at 1/2 thou. But on this one, I am going to set up a bottom of job. I don't want it to go in and try and machine all the way down to the bottom here. I'm going to tell it to stop when we get to this edge here. So I'm going to hold Control and Shift. I'm just going to zoom in on that edge, hold Control Shift, and click on that edge. And that just represents a reading from the top of the job, this origin, down to there. So I'll hit OK. And we'll see it's at minus 1.5. Again, this is a finish pass, so I'm not going to leave any allowance. Then I'll go next again. Right here for my leads, we got plunge, we got ramp, and we got spiral. I'm just going to leave it on plunge with a vertical lead in, but you do also have parallel, right angle, and circular. So I'll say vertical. Next, we have our options. So we have our boundary options. So again, we don't have a boundary, but normally the center of the tool is what runs along the boundary. And then for me, with this cutting extents that we have down below, I pretty much always turn on 3D extents if that's an option, because it allows the center of the tool to pass over the edge of the part a little bit extra if it needs it to make sure it gets a proper cut. We're not going to do any rest finishing or any angle ranges, so we'll go next again. Right here's our links, just how do we connect from one pass to the next. We got follow, direct, we got horizontal and vertical steps, a spiral, an S-link, or a full retract. I'm just going to say follow. We also could change where we link. So right here, by default, it just picks a side and kind of links down that side, but I could actually shift it by each subsequent pass. So you could work that line around the part. You could even come in and pick a start location. The way you do this is just by putting a point close to the area you want to start with, kind of where do you want to line up. In my case, I'm just going to leave the linking position off. Go next again. I have my gouge checking, which once again, we're not going to use. And finally, the advanced feed rate. So we have the convert rapid to feed, the lead in and lead out feed rate percentages, and the linking feed rates. When I'm all done and I can't hit next anymore, I'm just going to go ahead and hit compute. And we're just going to wait for these guys to calculate. Now, it may take a while to calculate, and a lot of that comes down to the processor in your computer. That's what's doing all the work when you're doing this. So the better processor you have, the faster it's going to calculate. But what I want to do first is I want to blank it out by right-clicking on where it says Feature 3-Axis and just saying blank unblank toolpath. And then I could see all these individually. So we have, here's our advanced rough, here is our flatlands, and here is our advanced Z-level finish. So it should be going in, giving us a pretty decent finish so far. The next thing we're going to do is these two slots, and they do have a chamfer on the corner. So I've set up a chamfer mill for them. but I just want to go in and mill these slots. And then with that same chamfer, I'm actually going to be able to use it for these holes as well. So I'm going to start by right-clicking on Machine Setup 1, and I'm going to go down to Mill 2 Axis, and then I'm going to select my geometry. Now the geometry for this is going to be the 2 floors of this part. So I'm just going to pick that floor there and that floor there. Whoops, right over here. Let me say none. Let me rotate and pick that floor. There we go. So now I have my 2 floors chosen. Now what you'll see is a preview showing you where your top of job is and where your total depth is right now. So the top's at 0, the depth is at a 1/2 inch. Now in between that, before we kind of pick that, we also have our chains here. So we have chain 1 and chain 2. And this allows us to actually pick where our start points are going to be at and what direction they're facing. So I'm going to go ahead and choose this start point over here. And I want to make sure it's going counterclockwise around that part. So I'll do the same thing for this one. And again, make sure it's going counterclockwise so that we're climb milling when we do our finish pass. Now the other change we need to make is right here, it's going to say pick top. What I want to do now is I want to go pick an edge that represents the top. And what I could do is just hold Control and Shift and pick just any edge that represents the top right there. From here, I could then tell it what depth I want to go, which is just by doing the same thing. Control Shift, and I'm going to pick the inside edge right there, and it's going to read that depth of 3/4 of an inch, so it knows how deep to go. From here, I can hit OK, and then hit Next, and we can actually see a preview of what we're cutting right there. Now, because I'm using a top of feature of -1.5 inches, the rapid plane is based on where our top of feature is at. So I want to make sure that I can clear over the center of that geometry. So the way I do this is I take my top of feature and I add it to my rapid plane. So I'm just going to say that this becomes 1.7 inches. But I'm not going to change the feed plane because I still want to do my feed in not from 1.7 inches above the geometry, but just from 0.1. So it's going to wrap it across, clear everything properly, and then feed in from 100 thousandths down. Top of feature again is at -1.5, and the total depth is 0.75. Then I could go ahead and hit Next again. Now for this strategy, we're going to choose the pocketing routine, which gives us a pocket and a profile finish. But we also want to do a chamfer mill. So just like we did with the 3-axis, over here under available operations, I'm just going to move a chamfer mill in. So we have a pocket, a profile finish to finish it to size, and then a chamfer mill. And the best thing is I don't have to do another chamfer mill. I'll actually be able to copy and paste this one over and over again. So I'll go ahead and say Next. Right here's our tabs. This is geometry. If we were leaving a tab that would hold on to the part, we would set this up here, but we're doing pockets, not tabs. So we'll go Next again. And right here for posting, we just want to make sure our work offset matches the work offset number we set it up to. And that's really it. We're not doing anything with this contour ramping because that's part of the profile roughing toolpath. So it's nothing that we really got to worry about here. So we'll say Next. So we'll see right here, it automatically picked my 3/8 flat. It kind of recognizes that the other tools don't fit in there, and we probably wouldn't want to use a ball mill right now. So it's got the right length. We have enough that we can make the cut. It's sticking out far enough that everything should work. So this tool should be fine. It's tool number 3. We have our coolant there set to flood. And again, I'm letting BobCAM figure out the feeds and speeds. These might be a little quick, but I could actually go in and adjust that and say 6,000 for my RPM is what I want to run at. And we'll see it actually adjust. And a lot of that's coming down to these feed per tooth and plunge feed per tooth that we have. This is pretty aggressive, so we could actually lower this down, say something like 0.002, and then that's going to be like 48 inches a minute. So we could make our adjustments in here, or we could just let BobCAM figure it out. But again, you may need to make some adjustments even then. Next, we then have our patterns. On the patterns page, we just tell BobCAM how to move around this part. So we have our standard pocket or advanced pockets. Now the thing is, a standard pocket has a parallel, an offset pocket out, and an offset pocket in option. The advanced pocket has a parallel, an offset pocket out, offset pocket in, but it also has a morph spiral and an adaptive roughing, so a high-speed machining strategy. The thing is, the offset pocket out and these advanced pockets, they have the ability to leave the geometry. They can leave the part if you do an open pocket. But I don't have an open pocket, so there's nowhere telling it that it's allowed to leave, so it's not going to leave. It's going to be a standard kind of pocket. So I always just end up using the advanced pocket, and I want to use an offset pocket out so it starts on the inside and works its way out. I'm going to tell it I want a climb mill. I'm not using any rest roughing. And I'm going to go ahead and set my step over to just 40%, and then I can hit next. Right here for our parameters, this is how much material we're leaving for the finish tool to clean up and where we're leaving it. So I'm leaving 15 thousandths on the side or the walls, and I'm going to machine the floors right to size. But down here, I get to tell it how many steps I take to get there. So what am I comfortable with that tool taking? So a single step means it's trying to do the full 3/4 of an inch in one shot. I'm going to go ahead and just do multiple steps, and I'm going to tell it the depth of cut is 1/4 of an inch. So I do 3 separate passes to get down to that total distance of 0.75. From here, I'll go next. I have my leads. I'm just going to plunge into the part. And then right here, I'm going to leave it as a single depth. So it's going to plunge down to 1/4 inch, make its cut, plunge down to 1/2 inch, make its cut, plunge down to that final 3/4, make its cut. Next, I then have my machine sequencing. Pretty much with this one, I'm only doing 2 pockets, so I really don't care which one it starts or ends with. But a good rule of thumb is to turn on optimized, and then it picks the best option out of either closest, no sorting, or the X or Y direction. The custom direction allows you to enter in whatever angle you want, so it doesn't really... But optimize gives us kind of the best of what we could choose. So I use that one. For the links, just how do we connect from one pass to another? We got direct. We have S-links or full retracts. And between groups, we got direct, S-link, or full retract. Next, we then have our advanced feed rates. So on the advanced feed rates for this one, we can convert our rapids to feeds. We could change our link feed rates. And right here, we have our adaptive feed rates. Again, we could set up a minimum. If we use the high speed strategy or the adaptive roughing, you will get more options for your adaptive feed rates. We also have a corner slowdown area. The corner slowdown allows us to define where we want to slow down when we're cutting in corners. So we can actually say slow down before you get a certain distance from the corner to maybe 50% of the feed rate, and then speed back up as you go through them. So you could slow things down, just better control of how the tool handles those corners. Next, we then have our profile finish. Once again, I'm going to use the same 3/8 tool. So I'll go to that 3/8 flat end mill, hit OK. There it is. Right here, we have our patterns. So we have just one pattern when we're doing a profile finish, and it's a standard cut. The whole goal of this toolpath is to just go in and clean up the 15 thousandths we left on the walls, and that's it. But we do have a choice of compensation. So left compensation is going to be our climb mill. And so I have the choice of either letting BobCAM handle the compensation or the machine handling the compensation. So outputting a G41. Or I can use both. So now this tool is compensated for, but I still have a G41 that's going to output in case I want to modify the diameter of that tool at the machine so I can get a proper cut still. Next, I then have my parameters. This is a finish pass, so I'm not leaving any allowance, and I'm taking it all the way to 3/4 of an inch for the cut. Right here for our leads, we got our plunge, we got our ramp. I'm going to go with a plunge. It's only feeding in and cleaning up 15 thousandths worth of material on the walls. So we just want to make sure we have something we can set up. So right here, I'm going to go with a lead in, and I'm just going to say it's a right angle lead in. And I'm just going to set the diameter here to, I'll say half the tool, so 0.1875. And that might be a little bit big for the fact that we've already compensated for the tool, but we really just need anything really over 15 thousandths, and that should be enough to get the tool away from the wall so that it could do a nice finish pass. So we'll try it there. We may have to adjust. Next, we have our corner types. So I'm just going to leave them on sharp. Really don't need to change these too often. Right here's our machine sequencing. Again, leave it on optimized. We're only doing 2 pockets. There's really no right or wrong way of doing it, but optimized will give us a good finish. And then right here we have our advanced feeds. Again, convert rapids, lead in and lead out feed rate percentages, and then the corner slowdown. And then right here we have our chamfer mill, which I do have. It looks just like this, kind of flat bottom, inserted chamfer mill. So I'm going to use that, say next. For the patterns, it's just like a profile finish pass. The difference is where our depth of cut goes and how deep we go. So I'm just going to set this to use that compensation just so I have that ability as well. And right here we then have our parameters. So the cutter position is the amount we shift over before we drop down. So I'll leave that at 20 thousandths. The small diameter of my tool, this was defined back on the tooling page, but it is 1/8 of an inch, and it's a 45-degree chamfer. It's a flat bottom tool, and then I have 3 ways to define how it's cutting. So I could say my chamfer depth, my chamfer length, or my chamfer width. Now I want to go ahead and use the chamfer depth, and I'm just going to set the depth here to 30 thousandths, just 30 thou chamfer around the edge. It's a small enough chamfer, I shouldn't have to do any multiple depths, but if you are ever doing a large chamfer, you could set up multiple depths as well as step overs to actually take out extra material or more material. But I'm going to do it with a single depth. For the leads, once again, I'm going to set up a right angle lead, and I'm just going to set the length to 1/8 of an inch because I've already compensated for this tool. Next, again, we have our corner types, which we'll ignore. We have our machine sequencing, which is optimized. And finally, the advanced feeds. Same page as the profile finish. So when we're all done, we can go ahead and hit compute and let it calculate. Shouldn't take too long. There is our geometry. We can see our rapids are clearing right over the top there. Everything looks good so far. So if I blank this one out, I can see here's my pocket. So right there's the pocket. Right here's my profile finish. And then finally, we have our chamfer mill right there. So the next 2 things we have to do is just drill some holes. So I'm going to right click on my machine setup 1. I'm going to do a mill drill hole. And I'm going to start by selecting my geometry. Now I can pick it multiple ways. For me, I'm just going to pick this cylinder wall here because that's going to define how deep it's got to cut. And then I'm going to hit OK. Right there we then have our 3/4 inch diameter hole. It's going to a depth of 1.47. And then right here, we can tell it whether it's a through hole or a blind hole. So I'm going to uncheck that and tell it it's a blind hole. If we leave it as through hole, we automatically add 50 thousandths to the depth of cut. So go ahead and say next again. Right here, we have our group retracts, which is essentially just using the clearance plane. And then we have our rapid and feed plane, the diameter of our drill, and then it's saying where the top of feature is and where the total depth is. So right here for our top of feature, I know I want to start at 0, so I'm just going to set that to 0. And then I'll say pick bottom, and then I can rotate this view a little bit so that I can see into that hole and hopefully get to the bottom edge of it right in there. And then I'm just going to hold Control and Shift and pick the bottom edge of this right here. So I'm just going to go ahead and pick right there. That's going to read the depth, and then I can hit OK. And then we'll see that it's going 2.5 inches deep. So from here, I'll just go next. On this page, we get to choose whether we do just a center drill, a drill, what do we want? So I'm going to choose a hole, which gives me a center drill and a drill. And it will have a chamfer, but I've already made that chamfer. So I'm actually going to copy and paste that in later on. Next again. Right here, we have our machine sequencing, which once again, I like to leave it on optimized. It picks kind of the best of the best. And then next, we have our posting. Nothing to change there. Then we have our center drill. I have a 1/2 inch, 90-degree spot drill here. So I'll say next again. And I'm just going to tell it that I want a center diameter of 200 thousandths. And so that's saying we have to go a distance of 100 thousandths. We could then come in and even peck out the geometry there. So we have 3 pecks going in to clear it out. And then finally, we get to the drill page. So it picks our 3/4 inch drill, which I already had set up. Sets up feeds and speeds, and then finally we have our parameters. So we have an effective depth of 2.5. The overall depth, or really where the tip of the tool is going to go, is a 2.7253. So that is calculating how deep the drill is going to have to go to give us an effective or a full depth at 2.5. And I'm going to go ahead and choose pecking on that one, and then I can go ahead and hit compute. And there is our drill. So then I could take this chamfer mill feature that I made and copy it right here. And then I could right click on my feature mill hole and just say paste. Now with that, if I right click on the chamfer mill and I just say compute toolpath, we'll see it calculates and computes it right there. So there is our chamfer for the 3/4 inch hole. And then finally, we'll blank out this last toolpath here. And then I'm going to right click on machine setup 1, go down to mill drill hole. And this time I'm going to go ahead and select both of the walls for those 2 holes right there. And from here, I'll just hit OK. And then I'm going to say pick bottom. So with this one, I'm going to rotate the part so I can see the bottom of it. And I'm just going to pick it right through to the bottom right there. So I'll just pick that edge, hit OK. And then if you want, you can tell it to go a little bit deeper. So I'll just say, let's go 1.25 total. And then I'll leave it on through hole. It'll actually add in an extra 50 thou for me. But if we look at this number, we got it at 1.25 right now. Right here we have our 3/8 diameter. Top of features at that minus 1.5219. So we'll go next again. Right here we're going to choose our hole, which gives us the center drill in the drill. Right here we have our sequencing optimized. Pretty much doing the same thing we did before, not much changing. There's our center drill. Go ahead and do the same center diameter at 200 thousandths. We'll peck it out. And then finally we get to our drill, which is our 3/8 drill, and our parameters. We'll notice that the effective depth went from 1.25 to 1.3, and that's because, again, we added 50 thousandths onto that depth. We peck it out, and then I'll hit compute. We'll see there's our two holes going through right there. Now, what we want to pay attention to is their relink right here. As we can see, they run right through the middle of the part. So what I need to do is go and edit my feature. And I'm just going to do the same rapid plane I did before. So 1.7, and then hit compute. And that way I could get it to clear over the top of that part. And then the last thing is I'm just going to take the chamfer mill once again and copy it. And then just paste it right on the same geometry. And then I could go and compute my toolpath. And there is our little chamfers right inside the inside there. So that completes the entire part. We're going to use the simulation later on in one of the later videos. I'm going to simulate it. I'm going to post it, generate setup sheets for this part. So we'll have all that stuff done. In the next video, we're going to take a look at some lathe work. And that concludes the video on the mill tutorial from inside of BobCAM for Rhino.